Hi, welcome to this webinar with COMAP and with me, Sophie Keloganian. I'm in charge of the training at COMAP, and today I'm talking about increasing the comfort and the heating network performance by using the auto-balancing thermostatic valves. The content of my presentation is as following. First, the reason why it's interesting to install auto-balancing valves on the radiators. Then I'll bring you back to the basic knowledge about static and dynamic balancing because it's not very well understood by everyone. Next, I'm going to describe the AutoSar technology to give the benefits of this technology, and I will present the full range of the COMAP products. A reminder about the way of adjusting the nominal flow in the radiator, and at the end some figures to show you how much we can save with the AutoSar technology. So let's start with the reason why it's smart to install auto-balancing valves. The example is a residential building where all the radiators are equipped with classic thermostatic valves. The heating network is properly balanced. That means all the radiators get the right water flow. Now, what happens when the heating network is operating? In January, for example, there are some sunny days. In the apartments that receive the heat from the sun, the thermostatic valves close because the ambient temperature is getting higher. In the apartments where there is no heat contribution, the valves remain open. When the valves close, the water has to go somewhere and overflows occur through the open thermostatic valves. You may say that the pump is going to adapt the situation and decreases its speed in order to reduce the water flow. That's true, but the pump can only see the pressure at its terminals, but the pump is not able to see the radiator terminals. It's too far, so it's not enough, and it's necessary to add something to improve the energy saving in the network. So we've just said that there is a water overflow into the network. As a result, an overflow in the radiator means too much heat. Too much heat means that it's not comfortable for the people because it's too hot, and it's also too expensive. Next, an overflow means also that the water velocity through the valve is higher. It may lead to noise, and it's not comfortable, and it costs money also. A higher velocity will also lead in time to the premature wear of equipment, and it will cost money. And third, an overflow will lead to a higher return temperature, higher water return temperature, and the boiler may not condensate. It also costs money. So when auto-balancing thermostatic valves are installed, there is no overflow in the network. That's the function of the auto-balancing thermostatic valve, to prevent overflow in the radiator. As a result, if there is no overflow, the comfort is guaranteed. There is no noise, there is no extra heat, there is no parasitic power consumption, so it's money saving. And as you are going to see in this presentation, AutoSar is easier to adjust. Now let's talk about static and dynamic balancing. I've tried to illustrate that with pictures. First, the static balancing. Imagine a tank. Here, it's a kind of tank with a tap above. First of all, the level of water is adjusted. In the heating network, we have to adjust the flow for every radiator. Now the installation is operating, and the tap opens. So the level is increasing. There is too much water. In the radiator network, some thermostatic valves close and some valves remain open, and there is too much water through the valves that remain open. As a result, for the tank, it's flooding. In the heating network, a water overflow occurs through the valves that remain open. In that case, the first thing was to adjust the level in the tank, or regarding the heating network, to adjust the flow everywhere. That's the static balancing. It must be done all the time. When the network is operating, it doesn't prevent overflow through the valve. Let's move now to the dynamic balancing. There is the same tank, the tap, but now there is a draining pipe and a draining valve. As previously, we start with adjusting the level in the tank, and in the heating network, we start with adjusting the flow. We said that's the static balancing. Now the installation is operating and the tap opens. So there is more water and the level is increasing, and as previously in the heating network, when some valves close, there is too much water for the rest of the radiators. But in this case, there is a draining valve, and so the draining valve opens and the level is controlled and remains the same whatever the water amount is added. In the heating network, AutoSar controls the flow and no overflow will go through the radiator. That's the dynamic balancing. On one hand, the flow is adjusted, that's the static balancing. On the other hand, we can add a flow control, that's the dynamic balancing. As a reminder, I recommend to watch the video called AutoSar, the Auto Balancing Thermostatic Valve by COMAP. It's in YouTube and the access is free. The video shows up a test bench and you will see the water overflow on one hand and the stable flow on the other hand when where AutoSar is installed. This video is available in different languages. I recommend it. So to sum up now what I've just said, static balancing must be done to set all new installations in new buildings and after a big renovation, such as the wall insulation, for example, because the heat which is needed after the insulation is changing. The static balancing is done on the risers, on the branches, on the radiators. It's efficient only if the flow doesn't change too much when the heating network is operating. The dynamic balancing is necessary when the flow changes in the heating network. So when the network is operating. It prevents overflow in the radiators. The adjusted nominal flow will never be exceeded. And the dynamic balance. So the dynamic balancing allows to optimize energy consumption while ensuring the comfort for the people. It's the best way to balance an installation. So now I'm going to describe the AutoSar technology. Here is the AutoSar, the auto balancing thermostatic valve by COMAP. You already know it because it has been on the market for 2 years now. Let's describe its technology. It's a thermostatic valve, so there is a needle. The spring is set to 4 kilograms. The part in gray here is for the kV adjustment. That means it allows to adjust the nominal flow. The seat here and the flow limiter that prevents overflow through the valve and through the radiator. Now, how does it work? On the right side, there is the high pressure just at the inlet of the radiator. The blue here is for the low pressure side. We are into the radiator. In order to control the flow, it's necessary to have the pressure information. So that's the function of the membrane you can see here. The information of the upstream pressure is given above the membrane. The information of the downstream pressure is given under the membrane. When the pressure is getting higher, here at the inlet, it pushes down the membrane. At the same time, the mobile part of the flow limiter here in pink is going down, and the flow area is getting smaller, so here, in order to avoid the overflow through the valve. That's the way to ensure a constant flow in the radiator. The AutoSar technology is the same for all the COMAP auto-balancing thermostatic valves. You can see on the slide the AutoSar Thermod for radiators with central connections, such as a towel dryer, for example. You can see on the cut of the product the needle, the spring, still set at 4 kilograms. The part in black is to adjust the nominal flow, the seat here, and the limiter, the flow limiter. There is more information. So the body is made of brass, and there are 2 stop valves here, and the blue cap, just to know that it's the auto-balancing thermostatic valve by COMAP. As the technology is the same for the full range of the COMAP auto-balancing valves, the way of adjusting the flow is the same. You can see a top view here, a top view of the thermostatic valves. The notch of the body here is used to select the flow. There is a key which is graduated in liter per hour. And for example, if we want to adjust 60 liter per hour, the figures has to be in front of the notch from the body. So it's very easy to set. Let's talk now about the benefits. I'm going to focus only on the product benefits. There are 2 key features concerning the auto-balancing thermostatic valves which are really important. The first one is the flow control accuracy. These thermostatic valves are supposed to control the flow when the differential pressure is between 0.1 and 0.6 bar. That means for the small and medium collective housing applications. You can see on the chart 4 curves for 4 valves. COMAP is here in red, and the 3 others are in green, gray, and yellow here. They are from competitors. The comparison was achieved in the COMAP laboratory in Lyon. As you can see, 2 valves don't control the flow in the low pressure zone, so below 0.3 bar. And the green here curve shows that the valve doesn't control the flow in the high pressure zone. Only COMAP, only AutoSar controls the flow on the full scale. So pay attention to that. Pay attention to the flow control accuracy. That's the first key feature of the auto-balancing thermostatic valve. The second feature is also really important. It's the lifetime of the valve. The product must be robust and ensure that the pressure information is right over time, and that the flow limiter is doing the job in the time. In the case of AutoSar, you can see here the flow through the valve. And you can see that the membrane here that measures the pressures is not in the flow. That means there is no risk to have particles that come on and under the membrane and prevent the pressure measurement. We can say that AutoSar is robust regarding the water quality in the heating network. So don't forget two important features, the flow control accuracy and the lifetime of the product. Now I suggest to describe all the COMAP solutions to connect the radiator. First, AutoSar, you know it. It's the right choice for the side connection of the radiator. The shapes, so it may be straight angle and inverse angle. The dimension of the head is M30. The O-ring is standard on AutoSar. And you can see here the pipe connection. COMAP provides all the fittings to connect with the copper pipe, steel pipe, multi-layer pipe, or PEX pipe. And before I forget, all the auto-balancing thermostatic valves are certified and are in line with the EN215 standard. Now the H module. It's used for the central connection of the radiators with integrated valve. It exists in the straight shape, angle right, angle left. The center distance is standard, 50 mm. The pipe connection is 3/4 Euroconus. And COMAP still provides all the fittings, whatever the pipe material. And the radiator connection is female half or male 3/4. We need the right adapter to connect the radiator. Now the AutoSar Thermod for the panel radiators, such as a towel dryer or a high panel radiator that needs to have the head at the bottom of the radiator. As previously, the shapes are straight, angle right, angle left. The head is M30. The center distance is 50 mm. The radiator connections are female half and male 3/4, and the pipe connection is 3/4 Euroconus. This product is used for the Flexo design by COMAP, which is a 4-in-1 solution and an aesthetic solution for the towel dryer, for example. The last product of this range is the kit hydrocablé. It's for a lateral collection of the radiator. It's a simple way to connect the radiator without thinking of an aesthetic issue. The result is aesthetic because, as you can see here on the picture, only the metallic part is visible and the pipe is hidden behind the radiator. It's also fast to install thanks to the press or slide fitting and the double O-ring here. It can be connected to the PEX pipe 12 mm. So what should be remembered here is that COMAP offers all the solution, whatever the kind of radiator you want to install. You can adapt the thermostatic, the auto-balancing thermostatic valve to the radiator, and you don't have to do the opposite. So it's a peace of mind solution. At last, now I'm going to give you some figures to highlight the benefits of AutoSar. A simulation has been done using a calculation tool whose purpose is to help the design office making the right choice regarding the network in order to save energy while keeping the comfort. The studied case was a residential building. The number of radiators is 54. The heat supply is achieved with the heat pump of 50 kilowatt and a boiler of 106 kilowatt. 4 different ways of balancing were studied. The first one is a reference with only thermostatic valves on the radiators. The second one, so the case number 1, was thermostatic valves and a static balancing on the branches. The case number 2 was the thermostatic valves and dynamic balancing on the branches. And the last case was with auto balancing thermostatic valves on the radiators only. The results of the calculation highlight that the network is more and more optimized from the reference to the case number 3, and auto-balancing valves give the best result regarding energy saving and efficiency. Let's see the figures. So you can see that with auto-balancing thermostatic valves, 14% on the pump energy consumption is saving. The heat pump contribution to the heat supply is more important, 7% more. That means the boiler is less used, and as a result, less gas is consumed. The global energy efficiency is 12% better, and as a consequence, the invoice is 8% lower. There is also an impact on the carbon print, which is better with the carbon impact 8% lower. These figures are significant enough to make us interested in AutoSar. This webinar is finished now, and I thank you all for participating. You can join us on CoExpert website, on the CoExpert website, and on the social media. See you soon for another webinar, and in the meantime, take care. Thank you. Bye-bye.